Welcome to Mathematics with Tom. I am Tom, and today we're going to take a look at the most simple differential equation. And an example. And that is this. It's the differential equation of y prime equals a times y. And here's what we've already looked at this, and we said that a solution is y equals e to the a times t. Now, notice this. I said this is a solution. There could be more solutions. So let me show you what this could be. This could also, I want to show you this, that y equals c, some constant, times e to the at is also a solution. Well, how would we check? I'll show you. I'm going to put a question mark. Well, what we do is we take we take the derivative of this equation and we see if we get a times y back out. So let's do that. So I'm going to take the derivative of the left side, so the derivative with respect to t of y, which is just dy dt, and we're going to take the derivative with respect to t of the right-hand side, c e to the at, and let's see what we get. So on the right-hand side, we get dy dt, which is y prime, and we'll write that on the next line. Now, when I take the derivative of the right-hand side, well, that's going to give me a c e to the at, and then remember, we have to take the derivative of the exponent also by the chain rule, so that's going to just give me an a. I'm going to rewrite this. This is y prime equals, I'm going to write it as a times c e to the at. Now, why did I do that? Well, the reason I did that is, look at this. C e to the at, well, that was y. That was right there. So I can write this as y prime equals a times y. Oh, but look at that. That is what we had to show. Okay, so our solution now, all solutions are y equals c e to the at. Well, and you could also write it y of t. What, though, is specific about c? Let's take a look at that. And that is this. Most differential equations, I'm going to abbreviate, most differential equations have what's called an initial condition, or a starting point. Have an initial condition, and it's usually at time is 0. I'll write all that. At time of 0. And so we'd write t equals 0. So remember, if y is a function of t, the initial condition at time equals 0 is y of 0. Okay, well, let's see how this affects it. So we just found that our solution is y equals c e to the at. And now let's use our initial condition. Use an initial, I don't even need to write it, we'll just say use y of 0. Well, what that means is we take our equation, so this is our equation. Let me put it this way. This is y of t equals, so now, well, y of 0, this equals c times e raised to the a, and now we're plugging in the 0. Well, that is going to just be c times e to the 0. Well, e to the 0, that's just 1. So in other words, y of 0 is c. So another way of writing your differential equation is y of t equals the initial condition, y of 0, e to the a t. And that is how we use our initial condition. Now, let's use this as an example. And that's what I want to do now. So we're going to do this. Invest $100 at 6% for 6 months. Then at 10% for the next 6 months. Find the value of the investment, at year end. Assume interest is compounded continuously. Well, what's so interesting about that? Well, remember, we actually solved that, and we came up with the problem x prime of t is equal to I, this is how we wrote it, times x of t. That's what the differential equation looks like. Well, let's solve that. We could use x or we could use y. Both are common. Our book uses y, so let's try y prime of t equals, well, in the first bit, it's going to be, let me write this, rewrite it. So y prime of t equals y of t. Well, in this case, what is I? I is going to be it's going to be 6% for the first 6 months, and then it's going to be, that's an ugly looking y prime of t, and then it's going to be 8% or 10%, sorry, for the next 6 months. So here we go. So we know the solution. That's just y of t equals some initial condition, y of 0, times e raised to the 0.06 times t. That's where we start. Now, notice that what it says. We start our y of 0. Our initial condition is that y of 0 is $100. So now we have the problem of y of t equals 100 e 0.06 t. Okay, now this will give me, this is going to be my total investment after 6 months, because then we're going to change the investment. So let's do this. So I'm going to call this y of 1/2 for the first 6 months, or half of the year, is equal to 100 e to the 0.06 times a half, and we'll just clean that up. That's 100 e to the 0.03. Okay, so this is the end of 6 months. But it's also something else. It's also the initial amount for the next 6 months. Well, how do we use that? Well, what we do is, notice our next equation, it's going to be of this form, y of t maybe I should call this, we'll call this y1. So y1 of t is going to have its initial condition. We know the general solution, initial condition E, the interest rate is 0.10 times t. Now, but wait a minute, it's not, the initial condition isn't y of 0, so maybe I shouldn't even write that. The initial condition is what we started with. Well, how much do we start with? We start with y of 1/2. Now, we could actually figure it out, but I don't want to deal with those decimals. So let's write it that y1 of t is really y of 1/2 e to the 0.1 t. Well, what we want is that money now grows for 6 months. So that means we need to grow this, y1, we need to grow this for another half of the year. Well, that's going to be y of 1/2, notice those are different, times e to the 0.1 times 1/2. Well, this is y of 1/2 e to the 0.05. Oh, but wait a minute. y1 of 1/2 is really y of 1/2. Well, that we said is 100 e, oops, up there, up above, sorry, from right up here, e to the 0.03 times e to the 0.05. Well, now we have the same base. We can add those e's. This is 100 times e to the 0.03 plus 0.05. So our total investment, I will call it y total, is going to be 100 times e to the 0.08. And you can put that in your calculator, and I think that this gives you something around $108.33. And that is how you use your initial conditions to value maybe an investment. And notice that the initial condition doesn't always have to be at time equals 0. It can change based on changing equations or changing circumstances. I hope that helps. Thanks for watching.